Well, ladies and gentlemen, today we're going to go ahead and make this wheel for the slot car project. The drawings provided show you the details needed to create this wheel. When you take a look at this, first thing we're going to notice is that it is round. When you are creating round objects, they can be revolved. So this is going to actually be a revolved profile. So you typically would look at this and see these diameters and think, oh, I can extrude those. The In reality, the quickest and easiest way to make this is the same way you would make it if you're making a custom part on a lathe, and that is to cut a profile and sweep it around an axis. So this center line is going to serve as our axis that we're going to revolve around, and this crosshatch shaded area right here will be the profile that we're actually going to draw. A couple important details. You notice our dimensions are provided in as the diameters for the object. But of course, when we draw this, we're going to be drawing half. So we're going to be needing to divide all these measurements by 2 for the diameters because, well, we'll be needing radii. The radius for the fillet for this circle right here, that is provided, so we don't need to do any math there. And the thickness for the back of the wheel is provided here in the detail view. So looking at our drawings, just a quick review. Here's the finished product isometrically. Here's what it would look like when you're looking at it straight on from the side or front view. Here's what you would see when looking at it from above. And this is a cutaway section view. So you can see that when I hover over this, the line B to B, the arrows on the left-hand side, is highlighted. So that's that B line with the 2 arrowheads. That is a cutting plane. So if we were to slice it along there and then stand here looking to our left, this is what we would see. All right, let's roll it over to the parts video, and this is the part we're going to make. Going into our profile, we're going to go, this is what we're going to finish with when we're all said and done. So for this demo, I will just draw another one right next to it. First thing we're going to notice is that there are all lines and a tangent arc. So this is an arc that runs tangent to this line right here, and then comes around about 3/4 of the way and stops. That knowledge tells me that I can do this entire sketch with just the line tool. I'm going to come over here. I've already have a line to serve as the revolve axis, so you'll want to start off by creating this line through the origin. If you want to, you can make it a construction line by selecting it and tapping the letter Q on the keyboard. That'll make it a dashed construction line. To draw this sketch, we'll go ahead and start right here and draw it down and across, making a horizontal line, and then down making a vertical line, and across making a horizontal line again, and then a vertical line that goes above my original starting point. And then I want to make this arc as I show there. Well, remember, we're in a line tool. We'll can't draw an arc with a line, right? Not entirely true. Bring it on back. There's one kind of arc I can make, and that is a tangent arc. So I'm just going to bring that around. To switch between the line tool and the tangent arc tool, just bring your mouse back to the end point of the line that you just created, and the tool will switch. If it doesn't happen right away, just go back and forth a couple times. It'll eventually get the hint, and the more often you do it, the more the software learns your habits. And there you have it. There's my general profile. It's time to start applying some rules here. The center point of this circle is actually vertically aligned with this inside face of the wheel. So we're going to the letter V on the keyboard or hit the vertical tool from our drop-down menu. And want to click the center point of the arc and the upper point of the inside line. Now I have my stuff how I like it. Things are moving in ways that make sense. And it's time to go ahead and apply our dimensions. Looking back at our drawing, our overall dimension was the largest dimension on the page was 1 inch. So that's a 1 inch diameter. So distance from one edge of the circle all the way to the other, 1 inch. Half of that will be half an inch. Go ahead and apply a dimension. Tap the D on the keyboard or click the double-headed arrow dimension tool up top. Right click on that horizontal line we started the drawing off with, and then come up to the top of our arc and click and release. Move the mouse over. That was a 1 inch diameter. Of course, we're dividing this by 2 to get our radii. There you have it. Next dimension, the center hole is 185 thousandths. So let's go ahead with that one. From the center line up to the edge of the hole, 185 thousandths, so decimal point, 185. And again, we're given diameter and we need radius, so just divide it by 2. And what else are we given? We're given the diameter for this wheel hub, the outer face of that wheel hub at 325 thousandths. So center point, side face of the wheel hub, decimal point, 325 thousandths. And again, we're given a diameter, we need a radius, so divide by 2. And okay, so that moves around that way. I'll pull this over so it lines up with my endpoint. If you begin yours above the origin, your parts will stick and you won't be able to move. Okay, so I'll actually apply a fixed constraint just to stop this from moving right there. Okay, so that is a good shape. Oh, look at that. There's something that needs to be dimensioned, and here's something that needs to be dimensioned. What are they? Go back to the drawing. Let's see, not provided in the front view. Radius 0.60. Let's go ahead and apply that. Remember, the shortcut for dimension is D on the keyboard. I recommend keeping your left hand on the keyboard and your right hand on your mouse. When you're doing these drawings, it is way faster than constantly using your mouse and not using your left hand. All right, so that 0.60 locks everything on the right side of the drawing. Last thing is to move, stop this from moving and apply a dimension to that. Not provided in the section view, not provided in the detail view, not provided in the front view. Oh, there it is, the overall thickness, 150 thousandths. So dimension the length of this line, the overall thickness, 150 thousandths. And that's not divided or multiplied because this is the actual size as it shows here. So that is a depth, not a radius, so we don't have to divide that. So there you have it, there's 150 thousandths. And I'm going to finish that out. Okay. I'm going to turn my sketch back on so you can see what I created. You see that's the same as the first one. Here's the example. To turn that into a wheel, the Revolve tool is next. I click the Revolve button. The dialog box pops up and it asks us for the faces and sketch regions to revolve. Oh, there's your face. Now it's turning red and telling me we're looking for the revolve axis, so we'll click on the revolve axis. and then click on that, and there you have it. There's my second part. Right-clicking on the name of the part that pops up down below, you can give it a name. And doing the same, right-clicking again, I can assign a material. And we're going to be printing these out of PLA plastic, so just type in PLA, and then search through the menu until I find PLA. There's PLA. Green check. And it's saved and correct. Now, my drawing provided some information to help us check to see if we got it right. It says the mass is 3 thousandths of a pound. Materials PLA are used as inches, so let's check the mass. In the lower left corner of the screen, you see a little scale, so it says display mass properties. So click on that display mass properties button. Click on the wheel, and you can see that the mass is 3 thousandths of a pound. So we got it right. Awesome. You can do it. Go be awesome.